Greetings everyone. Today we're going to explore graphing linear inequalities. We do have a foldable for this, but if you don't have access, all you need is some simple graph paper. One of the first things I want to review is remembering how inequalities work. And we're going to start off by plugging in a set of values and determining if it is true or false. So a review here, if I have an x value of 2 and a y value of 3, I'm going to plug those in accordingly, and all I need to do is simplify the expression. So I'd have 4 plus 12, which gets me to 16. And so my question is 16 less than 12? No, this would be false. So is it a solution? No. Let's take a look at this next one. If I plug in a 4 and I plug in a 1, you got to remember your order of operations. So I arrive at 8 plus 4, which is 12. Is 12 less than or equal to 12? Yes, it is equal. So because that or equals line is under there, that works in our favor, and we can say yes. We can also have inequalities where the y is isolated. So I still plug in the values accordingly. Simplify 0 plus 1, 1. Is 0 less than 1? In this case, no, this is false. It's not a solution. And then remembering that the notation f of x would be the same as saying y. So instead of f of x, I place a 1 in there for the y. All right? And in this case, I arrive at 1 is greater than 1. Is 1 greater than 1? No. There's no or equals to, so it is not a true statement. So just remembering again, true or false, reading it left to right, and then remembering that f of x we replace with our y value. All right, let's go through and identify some key steps for graphing linear inequalities. The first step, which is a review, is you need to graph the line. Now, if you need help with this topic, see the previous videos. That's what we've been working on the last few weeks. And keep in mind that that line can be in standard form. It could look like this, where you need to isolate y. It could look like it's already isolated in slope-intercept form. And it could also be in point-slope form. So all of these are still options for our lines. There's two pieces that are going to be new. The first piece is a solid or a dashed line. If it's or equals to, it's going to be a solid line because we're including it. It can equal that exact value. But if it's just less than or greater than, we're actually going to draw a dashed line because my values can't equal where that line exists. The second biggest new piece is we're going to shade our graph. So what that means is if I'm talking about all the values that are less than my line, then I need to shade all the values below that line. And so we're going to have infinite amount of solutions based on which side we shade on. And we'll work on that more on the examples. A reminder that when you are solving an inequality, if you multiply or divide by a negative, you need to flip your sign. Again, this is from the beginning of the school year with solving inequalities, and so just needing to remember that special rule. And don't forget about horizontal and vertical lines, what those look like, right? If I say x equals 4, that's a vertical line going through the x-axis at 4. If I say y equals -3, that's a horizontal line through the y-axis at -3. And what we're going to add to that today is you're going to shade possibly on the left side, or maybe you shade below the line. So that's how we're amping it up. We're going to apply solid or dashed lines, and we're going to shade one side of the line. Now we have some examples in our notes sheet to get us through and go through the steps. First step, we need to graph the line, but as I look at this, I need to isolate y. I want to graph this using slope-intercept form. So I'm going to zoom through this. If you need help with this piece, see the video about isolating y or graphing in slope-intercept form. Now, I've isolated y, but I just divided by a negative, so I need to flip my sign. There's that special rule happening right away. 10 divided by negative 2, negative 5. Negative divided by negative is positive, right? All of this is still true. It was just that flip that we need to bring back and remember. So let's graph that line. My y-intercept, my beginning on the y-axis is negative 5. We have a positive slope of rise 3, run 2, rise 3, run 2, rise 3, run 2. So we have that. Remember Mortvet's rule of 5 or fill. Now here's where we got to slow down. This is a greater than symbol, which means I need a dashed line. So what I like to do is just throw dashes in between the dots versus just connecting it all the way. You still need arrows on the end. All right. Now let's talk about shading. Oops, let's make a little note over here. So I have these boxes for solid and dashed line. It's going to be dashed because it's greater than. Remember, less than would always fall into there, and or equals to is when we have solid lines. Okay, but we're doing dashed because it's greater than. Now we want to decide if I'm going to shade above or below the line, and one of the ways we can do that is to use a test point, meaning pick a point on one side or the other. So I'm going to use 0, 0. If you can use 0, 0, I always suggest it because it's easy, right? So what I'm going to do is I'm going to plug 0, 0 into my original function. So instead of x, I'm putting 0. Instead of y, I'm putting 0. And just like we did on the first slide there, we want to see if this is true or false. Well, 0 minus 0, we have 10. We have 0. Is 0 less than 10? Yes, that's true. That's good. You know, however you want to think of it, it's positive, right? Because it's true, that means 0, 0's good. We want to keep 0, 0, which means we want to shade on the side where 0, 0 exists. Now, when you're doing this with a pencil, make sure you shade kind of lightly in case you ever need to erase and fix. You don't want it to be super dark and permanent in case you need to fix later. All right, let's try this process again. I'm given another line, but this time it's in point slope form. So let's identify our pieces. Our slope is the number in front of x, negative 1/2. Our point, if it says x minus 2, remember we write positive 2. If it says y minus 3, our y is positive 3. Now, if you need more help with that, see the point slope form video. But I'm going to plot that dot. My starting point exists right here at 2, 3. That's my starting point. My slope is down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And now I need to decide if it's going to be solid or dashed. Well, let's see. My symbol says less than or equal to. That means it's going to be a solid line, as always, with arrows on the end. Now we need to shade. I'm either going to shade sort of like above the line or below the line, but let's use a test point to make sure. Now I'm going to use 0, 0 again because it works out nice, right? If 0, 0 is on the line or not obviously easy to work with, don't use it. You can pick any point on the graph. I could use negative 10, negative 10. I could use 10, 10. I mean, it doesn't matter. Just identify that test point, and we want to plug it into the original function. Plug it in for x, plug it in for y, and then let's simplify. So the left side would be negative 3. The right side, that goes to negative 2. Negative times negative positive. Half of 2 is positive 1. Is negative 3 less than or equal to 1? Yes, that's true. That's good. That means 0, 0 is good. We want to keep it, and we want to keep all the values that are on that side of the line. Okay, so make sure you shade that entire chunk of the graph below my line. Let's review horizontal and vertical lines. This means I'm going to slice the x-axis at 1, x-axis at 1, which means it's going to be a vertical line. We've done that in previous lessons, but what we have to be careful of is this is a less than sign. So it's going to be a dashed vertical line, hopefully neater than what I'm drawing here. Arrows on the end still. And now we still need to shade. So let's think, if I have a test point, I could use 0, 0 again. If I have 0, 0, well, I can only plug in the x0, right? Because there's only an x, so let's do that. If I plug in 0 for x into my function, is 0 less than 1? Yeah, that's true. That's good. So that means we're going to shade the 0, 0 test point. We're going to shade to the left. Oh, look at that. X is less than 1, so we shade left, just like we did on our number lines. All right, let's try one more with a review of slope-intercept form. We have essentially a y equals mx plus b equation here, which means our beginning, our y-intercept is -4, so we're going to plot that dot, -4 on the y-axis. That's my beginning. And my slope, if I take a look, the number in front of x is 1. So that's a rise 1, run 1. If you need help with that topic, see the previous video. Now this one, the symbol is greater than or equal to. So because it's or equals to, that's going to be a solid line with arrows on the end. And now we need to shade. Well, let's use the point. I'm going to just use a different point to show you how that works. You can use 0, 0. But let's try a different one. Let's try 0, 10. Which means instead of y, I'm going to put a 10. Instead of x, I'm going to put a 0 and bring down the rest of the function. I'm using this function and replacing the letters with numbers. So if I simplify that right side, that would be -4. Is 10 greater than or equal to -4? Yes, that is true. That is good. So I want to keep the point 0, 10, which means I need to shade above this line. Now, one thing we didn't encounter, what if it's false? What do we do? If it's false, that just means you shade the other side, right? If your point's no good, then that means we need the opposite side shaded. Okay, so keep that in mind as you're working through our practice today. As always, make sure to see what that practice is on Google Classroom, see what our tasks are, check out PowerSchool, what do we need to catch up on. Let me know if you have any questions, and until next time, have a good one.